Next thing we're going to look at is solving an irrational inequality with test points. First thing you need to do is rewrite the inequality with 0 on one side and a ratio of two polynomials in lowest terms on the other side. We don't always have to do that, but sometimes we do, and it's important that we remember it has to be done. Then you find all the zeros for the polynomial functions in both the numerator and the denominator. The rational function is undefined for the zeros in the denominator because those would be what would make the denominator 0 and we can't have. And they give the locations of the vertical asymptotes if we were actually going to do the graph. And then you locate all the zeros from both the numerator and the denominator on a number line and test a point in each interval to see whether the rational function is positive or negative on that interval. Because you have it greater than or less than 0, we just have to worry about whether it's positive or negative. Now trying that, this one to begin with is not equal to 0. So doesn't have the 0 on one side. So getting that, we'll have x plus 3 over x minus 2 minus the 2 is less than or equal to 0. However, it's said that the other side must be a ratio of two polynomials. So we need to combine these. The common denominator is going to be x minus 2. We already have an x plus 3 from this one. So here, to make this over x minus 2, we're going to have to take that negative 2 times x minus 2. Still less than or equal to 0. That'll give me negative 2x and a positive x, so I have a negative x. And negative 2 times negative 2 will be 4, so negative x plus 7 over x minus 2 is less than or equal to 0. Now we'll find the zeros. For the denominator, x minus 2 equals 0, so x equals 2, and that's where it's undefined. And then for the numerator, negative x plus 7 equals 0, so x equals 7. Now we do these, we need a number line. So we'll get a number line. There's a 0. We need 7 and 2. At the 2, it's undefined, and the 7 is a 0. Now, between these, we need to check. So we need to check some value between negative infinity and 2. So let's say we use the 0. And we're going for this is the one we're checking, where it's the fraction. So that would give me 7 over negative 2, and that is a negative value. Now we have to check between 2 and 7, something here, and we can choose whatever we want. Say we choose 4. So that's going to give me negative 4 plus 7 over 4 minus 2, or 3 halves, and that's positive. And then we need something from 7 to infinity over here. So let's just use 8. So that'll give me negative 8 plus 7 over 8 minus 2, or negative 1 over 6. That's a negative. And we want this to be less than or equal to 0. Now, as you're doing this, remember the 2 is undefined. So the negative is here, negative infinity, to the 2, but because it's undefined at 2, even though it says less than or equal, make sure you use a parentheses. Union that. Now here it's equal to 0 right at 7. So there we can use the bracket, and then it goes to infinity. Let's try one more of these. Oh, but this one's nice. They already had it equal to 0. So we need to find the zeros. For the numerator, x minus 5 equals 0. So x equals 5, and that's a place where the value is 0. But for the denominator, we have x squared plus 2x minus 8 equals 0. That factors into x plus 4, and x minus 2 equals 0. So x equals negative 4, and x equals 2. Those are places where it's undefined. Drawing our number line, we'll put a 0 on. We need a negative 4, where it's undefined, a 2, where it's undefined, and 5, where the value is 0. Here's the 0, here's the 2 that are undefined. We need to check something over here from negative infinity to negative 4 between those. So say we pick negative 5. We'll have negative 5 minus 5, so that'll be negative 10 over 25 minus 10 minus 8, so this will be positive, negative. This is going to be a negative value. Then we need something between negative 4, negative 4 and 2. So let's use our typical 0. That'll give me negative 5 over negative 8, and that will be positive. Then we need something between 2 and 5. So let's use 3. Use the between, this is the between 2 and 5. We're using 3. So 3 minus 5 will have negative 2 over 9 plus 6 minus 8. That will be a 7, so that's negative. And then we need something from 5 to infinity. So say we use 6. 6 minus 5 will give me 1. 36 plus 12 minus 8, that's going to be positive. So we need this to be greater than 0. So we want the positive places, but it's just greater than, not or equal. So that would be here from negative 4 to 2 is positive in that interval. And it's also positive from 5 to infinity, and this would be the solution.